website and to the specific job applications after the event. Yeah, so keep your eyes open.
There's a job board in the Discord for anyone who is in a similar position. Also, the other side, if you are someone looking for a job, post yourself, intro, drop your resume there, whatever. This is collaborative and community, so you know, it's not going to be anyone just spamming you, calling about whatever. But what we hope to do is have this be a network community for people that the opportunity.
If you're looking for a new job, talk to Tony, who is a recruiter. He's our token non-technical. Okay, thank you, Joey.
All right, cool. Hi, everyone. I'm Joey. Today I'm going to be talking about programming networking ASICs. More specifically, the ASIC behind the product that I work on at Cloudflare called CNI. I'll explain what those terms mean in a moment. Yeah, hi. So I'm a software engineer. That's my core competency. This has involved a lot of knowledge about network engineering and systems administration, which has oftentimes left me feeling like this since joining this team. So if I say anything that sounds wrong or seems wrong, just let me know. I'm always looking to learn more about these fields. So yeah, hello. Just want to say I'm sorry about yesterday. That really sucked. Yeah, just that.
It was your fault.
I don't want to I don't know, pass blame or anything, but it was not my team. Our stuff kept working. Yeah, our stuff kept working. But yeah, we looked into it. We found the issue. There's a blog post about it if you're curious as to what exactly happened and how we'll fix it going forward. Okay, cool. But yeah, I work on the NSC team at Cloudflare. That's a recursive acronym, which is just amazing. It stands for Network Services, Cloudflare Network Interconnect. What are those things? CNI is basically our offering of a direct connection from a customer's router or a cloud provider's router that the customer uses to one of our routers, specifically this thing. And that requires being the same co-location as us, basically like the same data center, or they use a cloud provider in the same data center as us. It's an option for getting to their network services, which are products offered by Cloudflare, like Magic WAN, Firewall, Magic Transit. I won't be diving into what those are today. Just know that CNI provides access to those. And those services are specific to customers. The configurations are per customer. So for CNI, we needed a piece of hardware that can take packets from a customer and then encapsulate them into a GRE tunnel, because GRE tunnels are how we associate packets from a particular customer. That's just kind of an architecture decision that Cloudflare made. And we also want to be able to accept many high-speed networking connections from customers, so things like 10 gig, 25 gig, 100 gig connections. You might be thinking, why can't you just use a server for that? Servers don't generally have the ports at the speed and the quantity that we want to support. I mean, as you can see here, like this thing has way more ports than, I mean, this isn't a server, but even our Cloudflare like edge metals, they only have like 2 port NICs in them. You can buy 4 ports, but again, it's only like 6 ports. So, whereas this one has 24 for us to use. And also CPUs can only move packets so fast in software. There are things like DPDK or ways to get around the kernel and the processing time that the kernel does, but just doing it directly in hardware is faster. So if not a server, what else do you have? There are these things called ASICs, which stands for Application Specific Integrated Circuit. That's basically a fancy word for special purpose hardware. The benefits of that are lower power and cooling needs, and also the hardware design is simpler. Ours specifically is a networking ASIC, which performs L2 and L3 operations very quickly and really nothing else. We have a blog post about all of the ASICs we use in our network. This is just one of them if you're curious about the other ones. So yeah, for CNI, we use an ASIC called the SN2010. It's made by a company called Mellanox. We call it the Customer Connectivity Router, a CCR. It looks like this. It has 18 10 gig, 25 gig ports, as well as 4 40 gig, 100 gig ports. So it's 22 ports for us to use in total. And then we have like an out-of-band management port, which is twisted pair, and then a serial console port too. So this is what the architecture of the SN2010 looks like. It's basically an x86 machine with a giant PCIe switching device attached to it called the ASIC. We have an Atom CPU, we have some regular memory, some storage, UEFI firmware for a boot, And then yeah, just a big old PCIe device. So how do we go about programming an ASIC? Each vendor has their own like secret sauce that they want locked away in their hardware, which leads for heterogeneous software approaches. So like Juniper has their own network operating system, Cisco and Arista as well. There are some standardization efforts like Sonic that we tried when we first were creating this product, and they didn't really work for our needs. It could be getting better. We haven't reevaluated. There is a compatibility layer of Sonic, which looks promising, which we will evaluate. There's also P4, which is a programming specification for network devices. There just isn't very much hardware support for it. There was the Intel Tofino line, but those are end of life now. Like, yeah, Intel likes to kill stuff like that. And then there's a startup called Excite Labs that makes P4 programmable ASIC, but we haven't evaluated that either. Yeah, we chose Mellanox because of something called MLXSW, which is a switchdev driver in the Linux kernel. Switchdev is a subsystem of the Linux kernel that lets you program network switches. It basically interprets netlink commands and then translates them into the ASIC config. What are netlink commands? Those are basically what happens behind the scenes when you run things like IP route add, IP link add, these kinds of things. And then the driver will interpret those and then push them down into the ASIC. MLXSW is vendor specific, but we chose it because it provides a very familiar Linux data plane experience for us. There are other options for the SM2010. There's like a SDK, which is just a C and Python library, but then you have to figure out how to use the SDK, whereas this, we can just use Linux. They also have Cumulus Linux and Sonic, which have their own abstractions too, and we tried them out and they just didn't really work for our purposes. So yeah, the SM2010, like you saw earlier, it's basically an x86 machine, so we could just install Debian on it. We just need to have MLXSW loaded. MLXSW is in the Linux kernel source tree. You just have to compile your kernel with support for it. That just involves setting some, I think, environment variables or compiler flags when you build the kernel. So Debian does not come stock with that loaded, so I'm going to be using a pre-compiled kernel from someone who compiled it ahead of time, whose blog post I was following. Yeah, there is a caveat. Mellanox was bought by NVIDIA in 2019. NVIDIA doesn't really like MLXSW, so they told us it's end of life as a couple of years ago. There are no new features added. They will do bug fixes though. Yeah, we're evaluating new hardware and software now for future iterations of this product. Okay, without further ado, let's talk about or showcase the ASIC in action. We're going to go over some simple switching as well as some VLANs and some routing. Okay, so this is our first topology. Basically, I'm going to be having my laptop connect to the switch directly, and I'll be running iPerf on the switch, but it'll be hitting the switch's CPU and trapping to the CPU, so we won't see the bandwidth, the full 10 gigabit per second bandwidth of these links, provided all goes well. Okay. All right. All right, and the way let me walk through the equipment here. Right here I have my laptop, which has a fiber optic connection to the SM2010. This is device port 1 on SM2010. And then this is basically an office PC, just running a virtual machine server called Proxmox. And the VMs on that will also have connections through the SM2010. I'm getting to the SM2010 over a serial cable, a USB serial cable. And you can use something like Screen or PicoCom then to get into that. And then my connection to the VM server is just over Twisted Pair through SSH. And I'll be getting into the VMs with like virtual serial port on the VMs. Okay, so in the top shell here, I'm going to log into...
Could you bump up the text size?
Yeah, sure.
Thank you.
Tell me when to stop.
That's good for me.
It's fine.
Yeah.
Okay, cool.
Thank you.
All right, I'll make this full screen because I want to. Just want to print a friendly message real quick. Hello. All right. Cool. So in terms of in terms of replicating this topology here, I have a shell script that will do it. And the commands it's going to run are these ones. This first command, the devlink command, is just so that we don't rate limit anything hitting the CPU, which by default MLX system does. That'll just let us see like the max throughput we can get. By default, it only like limits it to 11 megabits per second, so this just removes that rate limit. Then we'll set the switch port to up, get rid of any existing config on there, and then add a address to that switch port. So down here on the bottom, I have a shell on my laptop. I have to run the script first. Okay, now I should be able to ping the switch. Okay, great. And now, and also just like to see what it looks like here on the ASIC / switch. It's basically just Linux. You have Linux data plane. We have an address assigned here, so yeah, all is good there. And now if we try a speed test from the laptop to the switch, we should see. Okay. So yeah, only about 2 gigabits instead of the whole 10 gigabit link because we're trapping to the CPU. And the CPU is just not that powerful. Okay, cool. So that's like the laptop to the switch directly. Now let's actually have it be a switch where we do switching frames from one port to another port. Here I have my laptop on one end of the connection, and then one of these ports will be the connection to the VM, and I'll just be turning the SN2010 into a simple layer 2 switch. I have a script here just to flush all of the configs for each of the topologies. Let's go ahead and run that now. And now we'll do let's take a look at the script for making this topology. Basically in Linux, you just make a special device called bridge. You add a link and it has type bridge. And then you add your different ports to the bridge, and then they will be bridged together at the layer 2. And then this will set the bridge to up as well as those switch ports to up too. Yeah. So let's go ahead and run that. And I'll just show you the config on my laptop too. This is it's a Thunderbolt to SFP Plus adapter. I just have an IP address assigned in the same subnet as the VM. And then this middle terminal here is the VM host. So I'm going to get a shell inside of the VM itself. Okay. And then this VM has this address shown here in the diagram. And now that these two links are bridged together, we should be able to ping from the laptop to the VM. And now just to prove that it is hitting the VM, it's the VM and not anything else, we'll do a speed test. And we should see the full 10 gigabit per second. It's not exactly 10 gigabits because there's overhead in the layer 2 and the layer 3 data. Like iProof is only measuring the amount of TCP data it sent, so you have to subtract some data for the overhead of Ethernet and the IP headers. So yeah, so that's it, acting as a switch. Let's do some more complicated switching where we have VLANs involved. So VLANs are a way to split your switch into basically multiple switches. It allows layer 2 connectivity for everything on the same VLAN and then does not allow connectivity for stuff on different VLANs. So I'll have my laptop configured as an access port for VLAN 10, which basically means my laptop sends untagged frames to the switch, and then the switch adds a tag of VLAN 10 to it. And then we'll also have 2 VMs connected on a different port that is a trunk port, which will only have tagged frames on them. So you'll have VLAN frame tags for 10 and 20. And then the other VM will also just be an access port. So to start with, we'll see that the laptop can only communicate with these 2 VMs. And it won't be able to communicate with this VM because it's on a separate VLAN. And the way I'm going to do that on the switch here is with this config. So yeah, we basically make another bridge device, but we then specify VLAN filtering. This makes it a VLAN aware bridge. Then we set all of the links to up, add all of the links to the bridge. And then in Linux, like adding VLANs to a bridge is with the bridge command. And these are basically the commands to actualize this topology here with all of the VLAN assignments. So yeah. So now that this server and my laptop are on the same VLAN, we should still be able to ping between them. Oh, all right, iPerf isn't running anymore, so it'd just be ping. Okay. Then we'll run iPerf again. We'll see that the performance is still the same, even with VLANs added. Cool. Now let's check connectivity to a different VM. This one here, Dairy, is I think VM 100 on this. Okay, now I should be able to also ping its address. Oh, I'm sorry, that's not running yet.
Did you ever run this?
I don't think I did. That's a good call out. Thank you.
Run the down script.
Yeah, thank you. Okay, now let's try it. Great. Great, cool. And then we'll do another speed test real fast. Great. And then let's get to that VLAN or that VM on VLAN 20. That should be this one. It has this address, 5. I should not be able to ping it. And now if I go ahead and remove my laptop from VLAN 10, and then add it to VLAN 20, I should be able to ping that VM now. Cool. And we'll do another speed test. Okay, cool. So that's like VLANs, that's like access ports and trunk ports. Yeah, and then let's see it also in action, the ASIC in action as a router. This will be like the most simple routing setup. Static routes from one subnet to another. So we'll run the down script again. And now do this script. So we'll add an address to one port on the switch, and as well as the other port, and then set them to up. The only thing we have to do to get the switch to be a router is this is the same thing for any Linux box. You have to turn on IP forwarding, which is a syscontrol command. This makes it like persist. So this will make it forward packets from one place to another. So yeah. Oh wait, this is the wrong picture. Anyway, that's the wrong host name, but we'll see how. Okay. Then I'm going to go back to the other server, or to the other VM. And now I'm going to change my laptop's IP address to be on the other subnet. And then ahead of time, I've already added a route on my laptop to get to the other subnet. I'll just run it again. I think macOS is fine with just doing that twice. And then I'll need to add a route on my VM as well. So that'll be something like this. Oh, I did this wrong. This will be this subnet's router. Okay. Now I should be able to ping to that same address again. And yet another speed test just to prove we can route fast as well. Okay, cool. All right, so that's the ASIC in action with a bunch of different, or some simple network topologies. And yeah, that's really all I had time for today. Oh yeah, features that we use that aren't pictured here just because it didn't really make sense to demo on a network all by itself, or like GRE tunneling, which would be a way to get from one network all the way to another, like on another portion of the internet. As well as VRFs, which are a way to like isolate ports from one another, just at the L3 level, instead of different bridges and different VLANs. So, yeah, these are the references that I used for preparing this talk. MLXSW supports a lot of stuff that I didn't demo here. Yeah, thanks for listening, and if you have any questions, I'm happy to answer them.
Stop supporting MEM?
They didn't really give us a reason why. My suspicion is like it's free and open source software, and that's maybe not their favorite thing in the world.
Sure.
Yeah.
I was going to ask, because switchdev is still being maintained, but it's like their driver. Because I looked this up recently, because you can. Is that yours? I assume that you didn't take that from work.
We each got shipped one for us. I mean, it is from work, but it's not like flash with any
You
work.
can find those online.
Yeah.
So, like they're a popular thing for home, like insane home labs.
Yeah.
But like, so y'all are evaluating alternatives now?
Yeah, and that'll involve since we can't use MLXSW anymore. I mentioned earlier there's something called SAI, which is like the Sonic Abstraction Interface or something like that. It's basically a way to have the same front end for every specific hardware vendor's networking back end. So Broadcom would have their own back end, Mellanox would have their own back end, Arista, that kind of thing. It's part of the Open Compute project, and there's I think 40 vendors that are participating in that. We just haven't tested it out yet. We're going to, because we want to get hardware that has more ports on it, that's fits the whole rack width, and also has higher speed ports. This one only has 4 40 gig, 100 gig ports, but we want one that have tens of 20s of 40 gig, 100 gig ports. So,
Do you typically have one of these switches supporting multiple customers?
mm-hmm. Yeah, basically each customer will get a connection into one of these ports.
Okay.
They'll run fiber from their portion of the data center into ours. It's called a cross connect. And we also will usually tell them to plug into more than one of these. We'll have them stacked in the rack. That way we can take one of them down for maintenance, and then you can switch over to the other one while we're doing maintenance on that one. And then we'll also have each of these uplinked into 2 different Cloudflare edge routers that are more general routers than these ones, so that we can take one of those offline at a time.
Yeah. So these connecting customer, that switch is also going to be then connected to the Cloudflare edge.
Yeah, and that's not the ports we use for that are not connected here. That we use these 40 gig, 100 gig ports for that. Yeah, I'm just showcasing what the customer does. So
I'm also a software engineer that does not know anything about networking. So how did you start to learn about this stuff? Because I've always vaguely been I should probably know something about how this works. I just never actually did so.
Well, I got a lot of help from my teammates who have more experience in that, so that was nice. Another thing that helped a lot was just setting it up at home. I mean, it's crazy, but I did end up setting a 25U rack. Bought some fiber optic switches. I mean, there's some relatively cheap prosumer ones. MikroTik really makes good ones. And then setting up things like VMs and connecting them to basically overhauling your home network or the home labbing community, that kind of thing.
You can get Arista switches that are 30, 25 or 48 gig ports for $400 on eBay.
My thing with those, and
Loud.
they're very loud and use a lot of power.
Yeah.
So that's why I prefer the more prosumer stuff. Some people like Ubiquiti. There's also MikroTik. They make more affordable, like passively cooled, as well as like lower power, high speed equipment.
I don't know Linux though.
Yeah, those have their own, again, like secret sauce, like proprietary.
It's all like
software.
you just have to choose what you're willing to sacrifice.
I mean, I heard that booting up early.
Oh yeah, as a fun thing, we can see how, like, if you don't load the right, like, the driver on here, like to tell the fans what to do, it'll just be really loud. But like, it goes in a data center, right? Like where there's not that many people. Maybe like one per soul has to deal with all of the noise and the heat.
So it's like that noise times 400 or something.
Oh, it's so loud.
How many switches are there in the data center?
I mean, I'm not sure like an actual count, but usually we'll have like 2 or 3 of these in each colo. I don't know. But like also, like everyone else's equipment too is just as loud.
Maybe we could get the audio programming shop and a couple of them.
Sorry.
White noise.
Yeah, does it help you sleep in your house when you have those things going? Yeah, great.
Sorry, what?
Does the white noise,
Yes.
does the reassuring whir of the fan gonna help you sleep if you're...
No. I'm
No.
trying to keep things as quiet as possible.
Have you guys considered doing your own hardware? Like,
Um,
I mean, not like
no.
like your own but like white label, like your own white label stuff.
I'm not sure. I mean, this is like pretty white label, right? I mean, like, I guess that white label would be like telling Mellanox to like make something for us, right?
Yeah, or you go to Broadcom.
I worked at Oxide until very recently. We build our own switches. We're actually doing a 2nd generation now, and it's a lot of fucking work is the thing. And so you need like management buy-in to like make that viable. It's definitely doable, but it's like that's like a serious initiative. It's not just like my team can do it. Like it's hard.
Yeah, and hardware is kind of like the problem child of Cloudflare. Like they like to have as little of it as possible, and testing it is like, I don't know. Basically, we try and do as much things in software as possible. Like we're not a hardware company. I don't really see us looking to develop any of our own hardware. We'll just have to have partnerships with companies that work for us.
I guess a follow unrelated, but have you guys considered just asking your customer to put in like a network card that's like programmable? So you just do instead of having a switch, because like you can do like they're like programmable like DPUs or whatever.
Yeah, I've heard of those. I just don't think that's very common for customers to have or want to do. For the most part, like one of the reasons we made this product was so that they can get to their like Cloudflare offerings simply just by setting this router as a next hop for their router for all of the stuff they want to go into Cloudflare. So they don't really have to do anything other than just be like, these routes send over to this link, and now they're in Cloudflare. Some people want to send us everything. Some people want to only send us some stuff. So, yeah.
Have you seen Silicon Valley?
I have.
It's the box.
It is the box.
Yeah. Awesome.
No, that's actually so true. Like Cloudflare for a long time was like, we're not a hardware company. The thing is, we don't sell this to customers.
Yeah.
They just plug in.
Yeah, we sell the services that are connected on the other end.
Yeah, we just charge them a boatload of money for all of the bandwidth they send us, or the traffic they send us over these links. We also do have something that's like more like the box, which goes in like an office building that does something similar to this, but just has fewer ports on it. That actually is like a mini PC. It has like 2 SFP plus ports on it and some Ethernet ports. It's more meant for like a small office, home office router. Yeah, that's called the Magic WAN connector.
Nice.
Yeah.
Okay, I think we're gonna move on, but thank you so much. It was a. Let's take